Hi guys, so today we're going to be talking about probability. You've done probability before in your previous math classes, but now we're going to get a little bit more and more complicated with our probability. Okay? So before we get started with example 1, let's look at our definition of probability. So the probability of an event is a ratio, often written times as a fraction, okay, that measures the chances of the event occurring. Right? So a desired outcome, what we are looking for, what we want, is called a success, and any other outcome than that is called a failure. And so the probability of success and failure here, so P stands for probability, the S stands for success, so the probability of success equals the number of ways you can succeed over the total amount of options, of outcomes, right? So that's why it's success plus failures. The probability of failures, right, capital P for probability, F for failures, equals the ways in which we can fail over the total amount of success and failures together. And when all outcomes have an equally likely chance of occurring, we say that the outcomes occur at random. So now let's get started with example 1. Okay. So Monifa has a collection of 32 CDs. 18 of them are R&B and 14 of them are rap. As she's leaving for a trip, she randomly chooses 6 CDs to take with her. And we want to know what is the probability that she selects 3 R&B and 3 raps. Okay? So because the order doesn't matter, right? It's just, is she taking it or is she not, right? It doesn't matter if she picked this one first or third or fifth or last, right? It's all that matters is it's part of the group. So this is a combination. Okay? So we're going to start by determining how many 6 CD selections meet these conditions. Okay? So here, for our 3 R&B, there's 18 of them, right? And then we're hoping that we get 3 of them, okay? And then for the R&B, we're hoping for, there are 14 of them, and we're hoping to get 3 of them. Right. There you go. Okay, so then we're going to put that over, simplify this. So this becomes 18 factorial over 18 minus 3 factorial over 3 factorial. And then for the wrap, it's 14 factorial over 14 minus 3 factorial over 3 factorial. Okay. So since this here is 15, this is 11, then what I am left over with is 18, 17, 16. 18, 17, 16, right? Because 15 and on is going to be canceled out with each other over 3 times 2 times 1, right? And then 14 factorial, this is going to be 11 factorial, so that means everything 11 and on is going to be canceled, so it's just 14, 13, and 12 over 3 times 2 times 1, okay? So then let's simplify here. 3 times 2 is 6, so 6 goes into 18 3 times, okay? 3 times 2 is 6, and that goes into 12 2 times. So then really it's just 3 times 17 times 16 times 14 times 13 times 2. Okay? And that gives me 297,024. Okay? So what that means is 297,024 combos are successes. Okay? Then we need to figure out how many possible total amount of groups can she have, right? And so then there are 32 CDs, and she's choosing 6 of them. Okay, so 32C6, that'll be 32 factorial over 32 minus 6 factorial over 6 factorial. Okay. 32 minus 6 is 20. sorry, 32 minus 6 is 26, so this will be 26 factorial. Okay. And so then this is, everything from 26 on will be canceled, so it will just be 32, 31, 30, 29, 28, 27 over 6, 5, 4, 3, 2, and 8. Okay, so then let's simplify. 6 and 5 make 30, so that cancels with this. 4 times 3 is 12, times 2 is 24, so that doesn't quite work. So let's do 4 times 3. Sorry, trying to divide things nicely. Okay, so we can do 8. How about that? So 4 and 2 make 8. 32 divided by 8 is 4. Okay, and then 27 divided by 3 is 9. Okay, and so then this becomes 4 times 31 times 29 times 28 times 9, and that gives me 906,192. So these are all the possible hands. These are the ones that are considered successes, so the probability would be my successes divided by how many there possibly are. Okay. And then we're just going to change it. You can do it as a fraction. Okay, so there's multiple ways to represent probability. So you can do it as a fraction. Okay, but sometimes that's hard to imagine, right? We can also change it into a decimal. So this is approximately 0.327778, or 32777 as the book writes. Okay, which is approximately 33%, right? So you can represent it as a fraction, as a decimal, or as a percentage. All of these are actually acceptable, right? So why don't you try CYP1, and then once you're done, come check the answer. Okay, you should have gotten 4,216,489,200 over 13,834,413,152, right? That's really hard to imagine what actually that is. So another way you could have also written it is as a decimal, 0.30478, which is approximately 30%, a little over 30%. Okay, and there you go. Okay, so now let's try example 2. So Ramon has 5 books on the floor, 1 for each of his classes. He has Algebra 2, Chemistry, English, Spanish, and History. Ramon is going to put the books on a shelf, and if he picks the books up at random and just places them in a row on the same shelf, what is the probability that his English, Spanish, and Algebra 2 books will be the leftmost books on the shelf, but not necessarily in that order? Okay. So what we need is we need to determine how many book arrangements meet the conditions. Okay. So basically, it's, since here our order matters, and then the 3 books, English, Spanish, and Algebra 2, right, we're going to pick all 3 of them. And then the 2 we don't want on the leftmost, which is Chemistry and History. There's 2 of them, and we're picking and hoping that they're in the back, right? And so the order matters in this case, right? So here, 3p3 is 3 factorial, and then 2p2 is 2 factorial. So that is 3 times 2 times 1 times 2 times 1, and what we get is 12. So there are 12 options where these 3 books are going to be in the beginning. Okay, so then we want to find the total number of possible 5 book arrangements. Okay. So here, possible is 5, and we're picking all 5, right? And the order here matters, right? Because we want English, Spanish, algebra 2. We're hoping it's in the front. So here our order matters again. So this will be 5 factorial, which is 5 times 4 times 3 times 2 times 1, which is 120. Okay. And then, so then we have what we want, our successes, over the total amount of outcomes, which is 120. Okay, this simplifies to 1/10, okay, which is 0.1, which is 10%. Okay, all of them are saying the same thing. So the probability of placing these books before the other 2 books is 10%. Okay, so now why don't you try this altered version of CYP2? The reason why is because in your book, the CYP2, you don't really need to even look at the example. It was just simple probability. So now I've changed it. And so now I'm asking, what is the probability that chemistry and history will be the leftmost books on the shelf? Although it does not have to be chemistry, then history, it could be history, chemistry. Okay, and basically you should have gotten the same thing. It's 12 over 120, which is 1/10, which is 0.1, which is 10%, right? Because you're still going to have 2 pick 2, because we want our chemistry and history books. Those are the 2 options, and we're picking, hopefully, that 2 of them are in that spot. And then the other 3, picking 3 of them in that spot. So that's why we still have 12, and there's still 120 options. And so that's why it ends up being the same thing. Okay. Before we move on to example 3, let's look at a couple of more definitions here. Okay. So many experiments, such as rolling a die, have numerical outcomes, right? That you roll a 1 or a 2 or 3, etc. So a random variable is a variable whose value is the numerical outcome of a random event. Okay, so it uses an example here. So for example, when rolling a die, we can let the random variable D represent the number showing on the die, right? So that's why D is what you get for the roll. So here, if we roll a 1, a 2, a 3, a 4, a 5, right? So that's why here we can say the probability that our number showing up is a 4 is 1 out of 6 options. Okay? So a probability distribution for a particular random variable is a function that maps the sample space to the probabilities of the outcomes in the sample space. The table below illustrates the probability distribution for rolling a die, right? So how is it distributed? We have 6 options. Each of them have 1, 6, 1, 6, 1, 6, 1, 6, 1, 6, 1, 6. So it shows that this is a uniform distribution because all the probabilities for rolling each of them are the same, right? Provided that everything else is even. Okay. To help visualize a probability distribution, you can use a table of probabilities or a graph, right? So that if something has a higher probability, that bar will be higher. If it's a lower probability, the bar will be lower. Okay. And so that's what we're looking at in example 3. Okay. So suppose 2 dice are rolled, right? Like when you play Settlers of Catan. Okay. The table and the relative frequency histogram show the distribution of the sum of the numbers rolled. Okay. We want to use the graph here to determine which outcome is most likely. Okay? And so here, if you look, right, so this is the probability distribution, and then they just graphed it, right, by what are the chances, right? And so here, if you look, the highest one, you want most likely, our highest one is right here, right? This bar here, and that goes with 7, okay? So, which outcome is most likely? Rolling a 7. So, rolling a 7 is most likely. Okay. And what is that probability here? If we look, it goes to 1/6. We can also see it here that it says 1/6. So, what is that probability? 1 out of 6 chances that you're going to roll. Okay. Then question B here says to use this table to find the probability that our sum, right, S stands for sum, that our sum is going to be 9. Okay? So here, probability of sum being 9, so we can either look here or we can look here. Either way, it says it's 1/9. So the probability of our sum equaling 9 is 1/9. Okay? What other sum has the same probability? Right. So what other one has 1/9? 5 does, right? Or here, if you're looking 9, the other one that has the same is 5. So what other sum has the same probability? Rolling off that. Or rolling a sum of 5. Okay. So why don't you try CYP 3A and 3B using that table again, and then once you're done, come check your answer. Okay, for 3A, you should have gotten rolling a sum of 2 or a sum of 12 is least likely. The probability for each of them is 1/36. And then for 3B, the probability that your sum is 3 is 1/18. What other sum has the same probability? That's 11. Right. So you can see that here. Which one has the lowest bar? That's 2 and 12. Right, so that's 3A. And you can see here it's 1/36, or here in the table 1/36. Okay. Probability of sum of 3 is here. It's 1/18, or you can use this 1/18. The one that also has a 1/18 is the 11 here. Or using the table 11. And there you go. So that's it for today. Have a great rest of the day. Bye, guys.